Okay, so now that we have learned how to find growth or decay for exponential growth or decay functions, and we learned how to find the initial value and find the growth or decay rate as a percentage, we're now going to interpret those values. So for number 1, Margaret is selling tickets for her school's first baseball game, but she notices that attendance changes by a certain rate at each game. The function y is equal to 1500 times 0.95 to the x power represents the number of tickets sold after x amount of games. So, is this a growth or decay function? We look at our b value. My b value is always the one that's being raised to the x power. Since it's in between 0 and 1, this is decay. Now it says to interpret the initial value in terms of the situation. Your initial value is your A, so that's 1500. And when it says in terms of the situation, that means put it into perspective of the situation that's being presented to you. So I'm going to be saying that the 1500 is going to represent the number of tickets at the first game. All right, because the initial value is where we start. Or you can say something like the attendance of the first game was 1,500 people. Because the number of people that attended are the number of tickets that they sold. So you could say that the number of tickets at the first game was 1,500, or you can say that attendance at the first game was 1,500. Now, we are going to interpret the growth or decay rate, in this case the decay rate, as a percentage in terms of the situation. So this is not 95%. Remember, what we do is we take our decay, our b value, 0.95. Since it's decay, I'm going to set it to 1 minus the percent expressed as a decimal. I'm going to subtract 1 from both sides. So I get a negative 0.05 is equal to my negative percent expressed as a decimal, dividing by negative 1. I get my percent expressed as a decimal is equal to 0.05. And then to write it as an actual percentage, I need to multiply this by 100 to get 5%. So what this means in terms of my situation is that the attendance, since it's decay, decreases after each game by 5%. Or you can say something like the attendance after each game drops by 5%, anything that represents a decrease of 5%. You can also say the number of tickets sold after each game decreases by 5%. Okay, so moving on to number 2, is this growth or decay? Derek is studying the population of bacteria in a vial every hour. The function is f of x is equal to 1,000 times 1.03 to the x power. Since my b value is greater than 1, this is growth. Interpret the initial value in terms of the situation. My initial value is 1,000. Since he's studying the population of bacteria, what that means is that Derek started with 1,000 bacteria in the vial. Then we need to interpret the growth / decay rate, in this case it's the growth rate, as a percentage in terms of the situation. So again, this is not 103%. To find the growth rate here, we're going to take my b value, which is 1.03. I'm going to set it equal to 1 plus my percent expressed as a decimal. Subtracting 1 from both sides, I get 0.03 is my percentage expressed as a decimal. To get it into percentage form, I need to multiply by 100 to get 3%. We're talking about the population every hour. So the bacteria, or we can say, sorry, the population of bacteria increases by 3% every hour. All right, moving on to number 3. The value of Jamie's car in dollars as a function of time in years is given by f of x is equal to 24,000 times 0.83 to the x power. Since your b value is in between 0 and 1, this is decay, so the value of her car is decreasing. She originally purchased her car at 24,000. So, Jamie purchased the car for $24,000. Now we're going to interpret the growth / decay rate, in this case it's going to be the decay rate, in terms of the percentage. Again, this is not 83%. We need to find our decay rate by setting up our equation. So the b value is 0.83. That's set equal to 1 minus the percent expressed as a decimal. Subtracting 1 from both sides, I get negative 0.17 is equal to my negative percentage expressed as a decimal. Dividing by negative 1 on both sides, I get 0.17. Whoops. Is equal to my percent expressed as a decimal. To get it into percentage form, we multiply by 100 to get 17%. So what this means is that the value of Jamie's car decreases by 17% every year. You could also say something like Jamie's car depreciates by 17% each year. The word depreciates means that it goes down in value. If you hear the word appreciate, that means it goes up in value. All right, and our last problem, number 4. So the following function represents an estimate of the number of Instagram users in millions per day since January 1st, 2009. And this is the function. Since your b value is greater than 1, this is growth, and your a value, your initial value, is 250, but this is the number of users in millions. So we are going to say on January 1st of 2009, because that's the initial day that we were assessing, there were 250 million Instagram users. Now we're going to interpret the growth rate. So I'm going to set my 1.10 equal to 1 plus my percent expressed as a decimal. Subtracting the 1 from both sides, I would get 0.10 is equal to my percent expressed as a decimal, and multiplying by 100, this gives me 10%. So interpreting what this means is that every day since January 1st of 2009, the number of Instagram users increases by 10%. And that's it.